All right, so today we are going to do a formula that is named Heron's formula. And this is the formula for finding the area of a triangle. And your first thought, I would think, would be, Ms. Collier, we already found the area of a triangle back in geometry and even back in middle school. Area of a triangle is 1/2 base times height. Yes, it is. But what if you don't know the height? Because oftentimes we do not know the height of a given triangle. Like back in geometry class, they contrived all of the examples that you would know the height. But sometimes in real life you don't know the height, you just know the sides of your triangle. So Heron's formula is a way to find the area of a triangle just using the sides. And it comes from trigonometry, but when you simplify it, it doesn't actually have any trig left in it. But the idea behind it comes from trigonometry. So the formula goes like this. Capital A for area. Let me write over here. This is area of a triangle. The formula goes like this. Capital A for area equals big giant square root S parentheses S minus A, close those parentheses, then S minus B in parentheses, and then S minus C in parentheses. That's it. That's the whole formula. You do not have to memorize the formula. You will be given a formula sheet or a list of formulas on the board. But what you do have to remember is what your variables stand for. So would you like to know what the S stands for? The S stands for semi-perimeter. The semi-perimeter is half of the perimeter, like a semicircle is half of a circle. So S means you just find the perimeter and cut it in half. Divide it by 2, cut it in half. What do you think the A, B, and C are? They're the sides of the triangle. All right, so here is an example. We're going to have a triangle. This side measures 6 meters. This side measures 7 meters. This side measures 9 meters. The height of a triangle is where there's a 90-degree angle. None of these angles are 90 degrees. This is not a right triangle. So we can't do 1/2 base times height, so we would do Heron's formula. So step 1, we find the perimeter. How do you find the perimeter of a triangle? Add up all the sides. 6 meters, added with 7 meters, added with 9 meters. $22 meters, yes? Step 2, we find S. S is the semi-perimeter. You take the perimeter of 22 meters, divide it by 2, cut it in half, you get 11 meters. Step 3, we just plug everything into the formula. S is 11 meters. So then we have 11 meters minus 6 meters, 11 meters minus 7 meters, and 11 meters minus 9 meters. Extend my square root. And it doesn't matter what order you put the sides in, because we're going to do subtraction and multiplication with each one. So then you type all that into the calculator, just being careful with your parentheses. Or some people like to do the subtraction with mental math and then type that into the calculator. Whichever way you prefer, I don't care. But step 4, you get down to your answer. If we round to the nearest tenth, what would our answer be? What did y'all get real loud? 21.0. What's our unit? Meters squared, square meters. I just want to talk a little bit. You know it should be square meters because you know that when you measure area, you're talking about square units. But I also just want to show you how algebraically we got square meters. I have meters here, right? So I'm going to come do a little thing down here. If I do the subtraction, I have 11 meters times 5 meters times 4 meters times 2 meters, yes? So I multiply that out and I get a number. And then what's my unit? If I have meters times meters times meters times meters, don't I have meters to the 4th power? And then if I take the square root of meters to the 4th power, won't that give me meters squared? So that's just showing you that your area is going to come out in square units, like area is supposed to come out in square units.